All right, today we're going to crack open one of the most famous boxes in all of science. You've probably heard of it. There's a cat, a bit of radioactive material, some poison, the whole setup. It's a story you think you know, but the real secret isn't about whether the cat is alive or dead. Not really. It's about what this whole bizarre thought experiment was trying to prove in the first place. So let's open the box and see what Schrödinger was really getting at.
Okay, so this is the question, right? The one that's made this whole thing famous for almost 100 years. And the answer that quantum physics seems to give us is, well, it's both, at the same time. But what if I told you that by getting stuck on that one question, you're actually missing the entire point of the experiment?
To get to that real secret, we first have to set the scene. We've got to build this experiment exactly how Schrödinger described it. So let's start with, the cat in the box.
We're hopping back in time to 1935. A physicist named Erwin Schrödinger, one of the absolute giants of quantum mechanics, he comes up with this scenario. And let's be clear, this was never a real experiment he wanted to do. Thankfully for cats everywhere, this was just a story, a thought experiment, designed to make a very powerful point. So inside this imaginary box, Schrödinger lays out this really elaborate, almost diabolical contraption. The entire thing, it all hangs on the fate of one single, totally unpredictable radioactive atom. If that one atom decays, a Geiger counter picks it up, that triggers a hammer to fall, which shatters a little vial of poison, and, well, it's game over for the cat. So you have the fate of a large living thing tied directly to the random chance of the quantum world.
It all boils down to what's essentially a coin toss, but at the atomic level. After exactly 1 hour, there's a 50-50 shot that the atom has decayed and released the poison, and a 50-50 shot that it hasn't. And from our point of view, standing outside this sealed box, we have absolutely no way of knowing which one of those things has happened.
And this is where our everyday logic just shatters, and quantum mechanics strolls right in. Because according to the standard way of thinking about quantum physics back then, the atom's state is uncertain. It's in a fuzzy state of decayed and not decayed at the same time. So if the cat's life is tied to that atom, then the cat must also be in an equally uncertain state. It is somehow simultaneously alive and dead.
Okay, so how on earth can something be two opposite things at once? To even begin to wrap our heads around that, we need to shrink down and take a look at the totally bizarre rules that govern the microworld. This is the quantum puzzle. You see, there's this massive disconnect between our world, the world we see and touch, and the quantum world. In our reality, things are definite, right? A light switch is either on or it's off. A coin is either heads or it's tails. But down in the quantum realm, the world of atoms and particles, things can exist in this haze of all possibilities at once. This totally bizarre property actually has a name, superposition. And it's a fundamental rule of the quantum world. A particle isn't in just one spot. It's in a cloud of potential spots. An atom hasn't just decayed or not decayed. It's in a superposition of both states. That is, until the moment you look at it. Now, Schrödinger wasn't just making this stuff up. He was directly taking aim at the leading theory of his day, something called the Copenhagen interpretation. And this theory basically said that, yeah, things stay in that blurry, all-at-once superposition state until the moment they're observed or measured. The very act of looking, of measuring, somehow forces reality to pick a side and collapse into a single state.
And that brings us to the big reveal. The whole reason Schrödinger put a cat in a box wasn't to celebrate this amazing theory. It was to show how completely and utterly absurd he thought it was. This was his actual point.
So here's the punchline. Schrödinger, the man whose name is literally synonymous with this half-dead, half-alive cat, he found the idea, and I'm using his own words here, quite ridiculous. He made up the whole scenario precisely because it was so bizarre and so unsettling. What he was doing was using a classic form of argument. It's called reductio ad absurdum, which is just Latin for reduction to absurdity. The idea is simple. You take someone's premise, you follow its logic all the way to its final conclusion. And if that conclusion is just plain absurd, then the original idea must have a flaw somewhere. And that is the core of Schrödinger's argument. He was basically saying, look, maybe this whole superposition thing makes sense for a tiny little atom. But if you try to tell me that the atom's fuzzy state can be transferred to a big thing like a cat, you get a ridiculous result. A cat can't be both dead and alive. So there must be something wrong, or at least incomplete, with any theory that lets this happen.
And that brilliant critique opened up this huge question that physicists are still wrestling with today. And it's the real reason why this imaginary cat has stuck around for nearly a century.
You see, the cat has survived for so long because it is the ultimate mascot for what physicists call the measurement problem. And this isn't some small detail. It's arguably the single biggest mystery that separates the weird quantum world from the normal, solid reality we experience every single day.
The Copenhagen interpretation says observation is what makes reality snap into focus. But what in the world counts as an observation? I mean, does it have to be a conscious person, a human, opening the box? Or did the Geiger counter already observe the atom when it checked for decay? Heck, could the cat itself be the observer? To this day, physics has no single agreed-upon answer, and the cat in the box sits right at the heart of that deep, profound mystery.
Now, Schrödinger's critique really pushed people to come up with some pretty wild new ideas. One of the most famous is the many worlds theory. This one suggests that when the atom is in two states at once, the entire universe actually splits in two. In one reality, the cat lives, and in a parallel universe, it dies, and both of them are equally real.
And that's really what we need to take away from all this. The health of that imaginary cat, it was never the point. The point of the experiment was to use this absurd story to ask one of the deepest questions you can possibly imagine. Where does the weirdness of the quantum world stop, and where does our solid everyday reality begin?
And so we'll just leave you with that, the final, profound question that's really hiding in Schrödinger's box. It challenges our most basic ideas about how the world works. You know, does a tree falling in the forest make a sound if no one's there? Or, to put it another way, does reality wait for us to look?